Well, good evening from Ohio for everybody. As always, joined by pxslip. Hello there. And we hope that wherever you are, you have a fantastic morning, day, evening, night, wherever your sleep schedule and/or time zone puts you. Let's see. Just a couple of quick updates. The website is updated. The YouTube is updated with some of the more recent episodes. So I'm not quite caught up. I've got a couple of the older ones that I need to fill in, but everything else should be there. So that's good. And I'll mention it again a little bit later on. But in my panel down below is a link and a note about the Business of Games Summit coming up February 23rd. And so that's a virtual event, of course, in this day of the plague. But it's linked down there. It's a good set of panels and speakers. Everything around the kind of more the business aspects of gaming and esports. So should be a good day. So it starts like at 10 or 10:30 in the morning and runs through about mid-afternoon. So should be good. And it is going to be on Twitch. It's going to be on a new channel we've set up for the McClure School on Twitch. So, and I will be hosting it here on this channel. That's on that's a Tuesday. I will be hosting it on here as well. That's about two-ish weeks. Right. So, plan for today. We're going to do an update on somehow pxslip has managed to start with, when we started streaming, we started building and started talking about building, and he started building the LST project, and then we add another project, then we add another project. So talk about feature creep. This wasn't feature creep within a project. This is project creep. So he's now working on three different projects or something like that. He'll give us an update and show us some stuff. Then we didn't have a ton of time last week to talk about WebRTC, so that'll follow that overview. And then we'll finish up, and I think I'll wait for the more detailed explanation until then. It'll sort of come up when we talk about one of the projects here. But we'd always planned to talk about containerization of applications, and of course it's something that pxslip in his day job has to think about, and being a web developer. But it's something that I've really, until like a year and a half ago, I really didn't have a terribly good concept. 2 years, I guess I taught a class last beginning of 2020. A cloud computing class, and towards the tail end of that class, we talked about and work with containers. But until I had to prepare for that class, I really only had a very fuzzy idea of Docker and containers and how to use them properly. And so we're going to spend some time this stream, definitely some time next stream, looking not just at Docker, but also at hopefully at Kubernetes at some point, and I have a particular project in mind. So when we get to that section of the stream, we'll talk about that. So with that, I'm going to hand it over to you. So you want me to put your screen up?
If you want to. I mean, there's not all that much exciting yet, but it is.
Okay. Well, let me know when. Let me know when.
Well, yeah, so you can go ahead and do it now. I have it set up, so.
All right, and I don't know. You sound a little. Your volume is
soft or tinny.
Tinny. I think the volume is normal, but you sound a little bit off.
I haven't changed anything, so I'm not sure what that's going on.
I'm just gonna boost your audio a little bit. I think maybe you're just a little bit soft, coming a little bit softer than usual. All right, so I'm gonna switch. I'm gonna switch to your screen.
Yep.
And let you kind of take it from there.
Yeah, nothing. Like I said, nothing terribly exciting from like a a front end standpoint, but it is finally like we were aiming to. It's finally talking to Twitch. So I have
Which
it.
which one of the projects is this? Yeah, I think you have to be
This is
extra.
sorry, yeah, excuse me. This is local stream tools. So like we talked about, we're the first major feature we want is for it to act like a stream bot, like a night bot, any of the other ones out there. There's some upsides and downsides, but running one locally is kind of nice because you control all your data. Downside is it's only running when you have local stream tools up, so it's not one of those persistent bots. Yeah, upsides, downsides, toss up. But like I said, we're talking to Twitch, so you can't see. Well, here, let me do that. So there's the chat in my channel. It's what I'm connected to right now. But you can see I'm getting the messages. It's not set up to send anything back yet. All it's doing is actually reading the messages out and adding them to a little array and displaying them. So nothing too exciting.
Where do I see, where do I see the
there's the chat output from the bot.
Oh,
and
okay.
That's my chat. So hello again. Sorry, I can't play with the.
Oh, there we go. There we go. I see it now. Yes. Yep. I see it.
Nothing too exciting there, but it is working, which was the big piece.
So that means you had to get OAuth working, right?
Mm-hmm. Yep. So we have a working OAuth implementation.
So you signed into your not signed in. You went through OAuth
local stream tools
to access your channel. Okay.
I actually can join any channel. Here, I asserted that. Let's find out if that's true. That should be right?
It should be just Prof Cruise, yeah.
Yep. And then I just need the right Twitch chat. I can join any channel. It can send messages to any channel it joins. It should not be able to do anything else. So
right,
like any other bot.
Yeah, because it's you
have to mod it.
Right. I mean, it wouldn't be a mod. It would, but it's. I'm curious that it can. So the bot. So it's still. Does it still have your identity as far as?
Nope. If I look, no, it doesn't show it as connected.
Because normally, it's only reading. It probably couldn't, because anyone can read a Twitch chat even if they're not logged in.
Correct.
It probably couldn't even post without.
It can, in fact.
Weird. So what is that based on? Because
I requested the privilege to post.
As part of the developer package.
As part of when I requested my OAuth token, there's a thing we mentioned called scope.
Right.
The 3 scopes.
But you don't have a token. You don't have a token for my.
No, but your channel, your chat is public. Anybody can join it.
Yeah, so I'm just saying, whose identity does the bot have right now?
It's if it were to create a message, and I'm sorry, I'm trying to think if I have access to. I don't think I can.
Don't worry about it. But you're talking about an OAuth token, which would imply that you've actually presented some credentials to Twitch, right?
Sort of. You can impersonate. You can choose any nick you want. It's essentially an IR. It is a superset of the IRC standard. So when I join a chat, I literally just set my nickname manually.
Mm-hmm.
So it is not automated. So I can log in as any user. Now, what I don't know is what happens if I were to try and authenticate using this token as you, for example, or me, even. Right, but I do know that I can. So
it is tied to a developer. It's tied to the registration of the app with Twitch, right? Is that when
really?
when you put the scope request?
Because I request scope when I request the token.
Gotcha. But I thought receiving the token requires someone to authenticate that, right?
Yes. So I did as pxslip.
Okay, so the bot
is operating
with a token that you've issued from your pxslip account, I guess is what I'm. Okay, that's
yes.
I was just wanted to. for my purposes and anybody else watching, this stuff gets complicated, especially so.
Yeah.
So the bot is operating with a token. Gremlin Wrangler, I love that name. Good evening to you as well. That's a good name. So we are pxslip is talking about the local stream tool, which is that local bot, and we were just talking about the authorization sequence and kind of the how these things tie together. So we talk about that and some of the other. Some of the OAuth part of it, and we'll talk about a couple of the other projects, and then the bulk of today we'll talk about WebRTC, which got standardized here just last month, formally standardized. It's been around for a lot longer than that, and then we'll talk about containers and do some run through some examples of containers. So that's what we're doing today. Hope you can hang out and kind of watch us do that. Welcome. Right. So okay. So you're when your bot LST interacts with Twitch, the token it uses is one that it was issued based on your authorization of providing your credentials. Okay.
Yes.
Okay.
What is strange, and I'm assuming Twitch essentially uses it as a way to audit a bot that was if a bot starts misbehaving. What is interesting is I have reserved essentially the local stream tools bot username.
Right.
And that is the default bot name. But there is no association between that account and who I logged in as.
Yeah. Right.
So essentially, I've used the account creation to reserve the username. I think essentially because if I were to try to join a chat where somebody already has that username in place, it would
burp. It would be a collision, right? Yeah, right.
But otherwise, I can log in as any name. It's how Nightbot can be customized, right? Nightbot can have any bot name in chat.
Right, because I have to authorize Nightbot to be in my chat. Yeah. No, and the reason I was asking is because if someone were to, go to Twitch, like to go to our channel right now, and they could watch the chat, but they could not interact with the chat because Twitch would force them to log in, because that's the only way you can ban users and that sort of thing. So. That's what I was curious about where the authorization was coming from.
Yeah,
Makes sense.
That's an interesting question. What happens if you had a bot that started chatting? I don't know how it manages bans. I'm guessing.
I don't know if it bans you or if it bans the bot.
I'm assuming it bans the bot, but I'm also assuming that the application client ID used to request the OAuth token probably gets some sort of a marker on it, either gets taken down or banned from chat.
Right.
I don't know how they track that piece.
Yeah. I mean, this is sort of there's all this federated bits and pieces, the bots and everything else. I mean, I think it's fascinating. I mean, we may be boring people out there, but I think this stuff is fascinating. So then we've got LST. So LST can basically listen in on a channel right now,
and eventually it will be responding. I was having a minor problem because that's the second half of what I've been working on. And forgive me, this UI is terrible. I have dark text on dark backgrounds. It's bad. But
there's text up there. Okay.
Yeah, technically there is. I have not fixed that.
You might have to enlarge it just a little. I don't know if that's a browser window, if you can enlarge it or not. But,
I can. It's just annoying because it's the...
That's all right.
No, I can do that.
There we go. Yeah. I
mean, there's nothing special here. This doesn't actually do anything yet. The code is literally commented out right now because it was throwing an error right before we started.
Of course it was. Yeah, of course.
But eventually, right, the idea is that, you have a couple of different types of commands, a chat response or an OBS action. And with an OBS action, it will populate with an action and then, the action name. And then if there's a secondary piece of parameter, and then this code will happily listen to it. I also want to set up, custom prefixes because bots like custom prefixes. But yeah, other than that.
Cool. Right, but the nice thing here is that I mean, the OAuth, of course, was kind of a big stumbling block to get working, and once you have one API linkage in place, it gets at least
Oh
conceptually a
yeah,
little bit easier to.
from here on out, it should be relatively straightforward, right? It's just expanding my scope, and if I need to, uh, and just hitting different endpoints at different places.
Right. But it's at least in principle, OAuth will kind of work the same way, and might like the scope definitions might not be identical between different services, for example, but otherwise we should have an easier time, I suppose, working with the next set of services.
Yeah.
So the next big thing, and we really have to think about how to, maybe containers are the answer. I don't know.
We'll
The
do this
containers are
properly on
virtual
stream,
machines, but the connection with OBS is going to be the next kind of fun thing to.
yes, that's going to be the big piece. Yeah, and as far as how to show that on stream, yeah,
Yes.
that'll be interesting.
We might have to run OBS in a VM.
Yeah, that's kind of where I'm leaning right now, is figure out how to get OBS up and running in a VM, and then run local stream tools in the VM as well.
Yeah, that's what we would have to do. But that will give you a separate instance of OBS.
Yeah, fortunately, I think I have all the pieces I should need to just spin up a quick.
And I have I have a Windows VM running. That I can just that I can remote desktop into if I wanted to. So certainly possible, but that's going to be the next fun thing, is to get the local inter-process communication between the Electron app and the and OBS working correctly.
Or WebSockets.
Oh, WebSockets, right. Right.
So I think that's all the LST has to show now.
Okay.
What I can jump into, and I thought you were talking about this a second ago, but I'm spoiling the future a little bit. There's the Docker file that I started just putting together to get my ideas out. I'm calling it FF Pro Visualizer, bitrate visualizer, whatever you want to call it.
Mm-hmm.
We finally have, and let's see if this still works. I haven't tried the debug command in a little bit. It should work. There it goes. Curses.
Windows and dragging and snapping stuff is.
Yeah, it was being a little weird for a second there.
Yeah.
Well, it was updating itself.
That looks better. That looks better now.
So that is actually, I think, roughly accurate.
Yeah, we looked at it. There was that transition, so there was a. Right, so just as a quick recap for anyone who doesn't recognize the project, so there is an old abandoned Windows piece of software called Bitrate Viewer that can analyze a video file and provide a visualization of frame by frame bit rates, in effect. And so on previous streams, we've looked at various ways of kind of replacing that unsupported piece of software. It's sort of running around as an exe you can download from Bob's aluminum siding and old Internet Program repository.
You mean Four Seasons Landscaping?
Yeah, Jesus, yes, that too. So we were looking at different ways, and if you go back to some of the older VOD, like a VOD from a week or 2 weeks ago, I did something with GNUplot, which worked pretty well, and pxslip was working on something that takes the video file directly into a Python app, runs FFprobe automatically,
and you get this,
and then visualizes the output, and that's what we're looking at here. Which is pretty much what you would get with Bitrate Viewer, except this one's kind of nicer because you can zoom it in, you can enlarge, you can zoom it, that sort of thing, which I don't think that one can do.
Well, the one thing I cannot for the life of me figure out is I just sort of because I was curious and I
Mm-hmm.
saw you could do it. I attached all of the frame details in here. Now it overflows
Right.
the container and it's terrible
Right.
UI right now. But for some reason the large frames don't show that. Haven't figured out why.
I think no, that it's scaling correctly, right? So you're not.
Hmm.
Yeah. Oh, weird.
But yeah, so if you here, I can show a little bit better
Yeah.
if I do this. So here, this
Yeah.
one I'll
There it
get,
is.
right? All the data. This one, I'm hovering over it,
How strange.
right? But if I go to the next one over, there it is.
Very
Now,
strange.
I have a couple of wild guesses. If it may be failing. There's like a keyframe or a piece of data that, if these are like keyframes or something like that, there's a piece of data that's borking something and it's failing in that to add the data on those particular frames. That's just a guess. I haven't debugged that
Mm-hmm.
yet. I will eventually.
Yeah.
Um, but yes, no. So yeah, that is working. So yeah, I think like I said, spoiler. I think probably not this week, maybe next. We'll play around with turning this into essentially a distributable Docker image,
Mm-hmm. Mm-hmm.
which
Mm-hmm.
would be kind of cool.
Yep. And so yeah. And so this was kind of. I mean, we had talked about doing some of the Docker even before this, right?
Hmm.
But this particular application was one of those things where we talked about trying to distribute something with Python kind of wrapped up
Hmm.
in somehow in an executable, which you can do, but it is it is a really onerous process
Yeah.
and kind of error-prone process. And any sort of attempt at just distributing the Python script gets kind of tricky. I could do it with something like MyScript because it is basically doesn't rely on anything other than a sort of a system installed Python. But in this case, there are 4 or 5 or 6 packages required,
I think more than
and
that. I
and
can
they
show
may
you.
not be they may not
There you go.
always be yeah it's a long
30.
list, and they may not always be compatible with what a user's
Yeah.
already installed or a project the user's using. So now you have to assume that the user knows how to create virtual environments for Python to keep things clean, and it just gets more and more complicated.
Yeah.
And because and this is something we're still kind of thinking about if it's doable or not, because this tool requires a large input file. In this case,
Yeah.
the video file, right? And I mean, I don't know about yours, but I know my sample file was the really high quality one was like 400 meg or something. Nothing super big, but still not
Mine's
small.
under 20 seconds long, so
Yeah, mine was 2 minutes, and at high quality it was running like 400 meg, and some of my more compressed stuff was running like 50 or 60, 50 meg, 40 meg, that sort of thing. But obviously you want to be able to do this on like on our stream videos, right? And those are those are about a gig plus, and those are compressed already. So it isn't trivial to think of a cloud service that can sort of routinely handle multiple users throwing
yeah,
those size those kind of file sizes at a cloud service.
no, cloud
With
services do not like that.
not one that pxslip or I would want to just sort of throw up for fun because you'd have to
Hmm.
probably put some significant resources behind it.
No, as the minute you're dealing with multi-hundred megabyte files,
Yeah.
you're talking some
That
serious money.
yeah, they're not. This is not a terribly good cloud service application. It's kind of awkward. I mean, in many ways, I think if you're watching and if you think about cloud services, they tend to provide information. There are very few that are designed for you to put things up. Some of the exceptions might be like Google's photo site. Some like things that a few things that let you. There's some online PDF editors and some other things, but they're generally meant to work with relatively small files, and a lot of the photo collection services have size limits, right? So you can't upload arbitrarily large images. So anyway, make a long story short, I mean, this isn't a super good example of a easily cloud deployed
Mm-mm.
platform. So So the middle ground here and again, it wouldn't right now. Having even like a video producer's workstation have Docker or Docker Desktop on Windows installed is pretty unlikely, but I think it's going to become more and more common. And for developers, I think it is nowadays. pxslip, you can speak to that. But I think for developers, it would be pretty much the norm. They would have some sort of a a
More
local
and
Docker
more,
install, and more
certainly,
and more.
yeah, certainly anybody on sort of the more pushing the more modern development. Obviously, there are developers out there who are set, are happy with their workflows and don't feel like trying new ones, and that's that's their prerogative.
Yeah.
And they may not, but yes, by and large, someone who's interested in new, the way things are being done, it will have Docker.
So there's this sort of Venn diagram between people that want to do video file analysis, which is in and of itself kind of a geeky thing to do. I mean, this is not something you would do if you're just kind of worried about the aesthetics.
Yeah.
You would have to because there are things like media info, which gives you a pretty good overview, and there are some. We haven't played with them on stream because they're all paid tools, but there are some really good quality analyzers that use kind of industry standard video quality metrics. But you have to pay for them.
FFmpeg under the hood anyway.
They might, but actually they're doing. There are actually some industry standard algorithms you run on the actual content of the frames to basically to come up with quality metrics. I said I haven't worked with it. It's kind of out of my wheelhouse in a lot of ways. So on the sort of the aesthetic side, you would I mean there are people would run those kinds of tools around media info. If you're planning to stream stuff, then something like bitrate visualizer is something you want. And clearly the author of the book I mentioned a few streams back that I used for not the FFmpeg book, the other one, the video encoding book, certainly is promoting that bitrate viewer program even now in its abandoned form, because it's kind of the only thing out there to do that. So this is an analysis that if you're kind of on the technical end of the I thought I saw ODG coming in here. ODG, welcome. Glad to have you in our stream. Thanks for the shout out, and thanks for the ASCII graphics as always. Good to see you, ODG. So we're just in a tail end of I think you've seen us work on this, chatting about this video bitrate visualization tool that pxslip has been working on and how to deploy it. I think you were in the stream when we talked about like Python packaging, and so what our discussion is at right now is the thinking that there's a subset of people that want that information about their video files, and that also either have the ability or already have installed Docker. Yes, the bitrate app. Yeah. So we're basically saying there's sort of two ways for someone to get a hold of this app when it's done and we're ready to put it out, which will be pretty soon, right? It looks like you've got it almost done.
At this point, I'd put it out. I might. Well, it might be a conversation for next week when we try and Dockerize it about how we want the server to actually spin up. May or may not leave it sort of doing the default server the way it is this way, or
we'll need. I think we'll want to tweak that to make it work best with the Docker image. Mm-hmm. So I think what I'm getting at is I think our deployment options for people. So it'll be probably a GitHub repo.
Oh yeah, without question, it already is.
Right, and so I think there'll generally be two ways for people to get a hold of this thing. One of them is you could clone the repo, create a virtual environment, and
pip
do
install
a pip
requirements
install, and
.txt.
then do a pip install requirements, and then you're in that environment. You're off and running, do your own thing with the Python script natively. But then the other pathway would be to pull a Docker image from Docker Hub, but you would have, because it would need to have access to your local video file. It would, you'd have to, you couldn't run this in a cloud service. Well, if you had your own cloud service and ways to put files in there, you could. But from our perspective, we would provide the Docker image with the idea that you you pull the Docker image down, you map a local directory to something the Docker container can see, and so it can run the analysis, show the results, and then when you're done, you shut the container down, and kind of everything cleans itself up neatly. Yes, ODG, that's exactly what we're planning to do. Today, and we're going to take a detour here and talk about WebRTC, because we didn't quite get done on that last stream, but I'll try to keep that relatively short so we have a bit of time to do this. But yeah, so we're gonna look at Docker locally with something a bit simpler with iPerf, just to kind of get a feel for how that works. But yes, we will go through the process of I think probably not with the iPerf thing I'm doing, although eventually I'll set something up for that. But that's going to go a different path, and I'll explain that in just a little bit. So I think next stream, maybe, if you're pxslip, it depends on whether you're ready or not for that. But if you are, then next stream maybe we package this into a Docker file, into a Docker image, and push that up to Docker Hub.
I think we can kind of kill two birds with one stone, actually, because what I'll do is we'll set up a GitHub action, sort of show off CI, CD.
Oh yeah, that'd be perfect. Yes. Yep, that would be perfect. So we'll basically use the GitHub action to build the container image.
Mm-hmm.
Yeah.
Yeah, you build the container image, and then you would authenticate and push it up to Docker
Hub, and version it, and push up to Docker Hub. Yeah. And ODG, we were talking about briefly right before stream about that NPM hack you analyzed it. You looked at the video and analyzed it on your stream. So one of the things that, hopefully we'll get to that at some point, either today or more likely when we do the set up the bitrate visualizer. There are some precautions, and I don't know enough about NPM to know if they apply there, but there's some precautions you can take to avoid that sort of hack that caught these folks. Because as you explained in your stream, when you pull Docker Hub images or NPM packages for Node.js development, you sort of relying on a kind of a system of staggered dependencies. Like a Docker image can obviously depend on another Docker image and that sort of thing, and NPM packages have lots and lots of dependencies, and if they're not set up very carefully, somebody can override a package, an intended package target with a different one, which is what happened at NPM hack. And so one of the things that we were talking about is there are actually some things you can do to narrow the attack window, because you can force like in the example you showed, there's an effective way to say pull package XYZ out of my private repository, and if there's a public package called XYZ, it won't get pulled because it doesn't match.
I said the where that one came from, we were talking about. So from the Docker image
right.
naming. Composer has always done this, and Composer is the PHP dependency management. You may have run into that one, ODG. Um, uh, they require an organizational prefix on all of their all of their dependencies, right? So
That's for
everything
PHP. That's for
must be
PHP, not for Node, or is it? Does it
correct. Yeah,
apply for both?
Composer is the PHP dependency. It's the PHP version of npm.
Okay.
Um, they have always required prefixes, and Node is moving that direction. They have introduced prefixes, organizational prefixes. They just went the original architecture did not include that. So I imagine that is a bit of an ad hoc add-on that is becoming standardized as we go. But yeah, they were just talking about that. That is one of the quickest ways that you can avoid that one, because if
Yeah,
you
as
control your
ODG says,
prefix,
the issue is not knowing where the images are coming from. If you have your own private
yep,
image repo and then there's a public one, and then and your package manager pulls a public one when you meant to pull the private one.
yeah, that one is an issue of precedence, right? Where what
Yeah,
is the precedence? And
right.
npm had it backwards.
Yep. Yep. Is that? Do you know if that's been fixed in some way, or is that still an issue if you don't set it up correctly?
I honestly have no idea. I
Okay.
haven't seen npm's response to the
Hmm.
attack. It's a known. The thing is, it's
I
a
mean,
known
this
issue.
sort of poisoning is
This
a known issue. I mean, this was a
we've
particularly egregious case of it, but the
Yeah, I mean, someone took advantage of several large organizations not properly configuring how they do things.
yeah, yeah,
Um,
yep.
but this supply chain issue, I mean, it's been 5 years since LeftPad,
Hmm.
7 years since LeftPad, something like that.
Yeah,
Um, right. So LeftPad was sort of the original 0 day. We broke the internet with a supply chain issue, when someone pulled their library out of npm, and it just broke the entire internet.
right. Yeah,
Obviously not literally, but
and I think sometimes Node.js, folks are somewhat going overboard creating npm packages. I think there's one that literally does nothing but convert the string to uppercase.
no,
Uh, eh,
this is the left pad thing. Left
yeah,
pad literally added padding to a string on the left. That's it. It was like 3 lines of code.
yep.
So
So
it's
yes,
we,
so
we
that
have
yeah,
it we have a dependency problem. At the
right.
same time, I mean, that's modern web dev, right? I
Yeah,
mean,
I mean
everybody
that's yeah,
depends on something.
yeah. And in this case, as ODC says, this one was PayPal that produced the packages, but in Apple, Microsoft, and so on did not have either PayPal or Apple. Probably more likely the developers at the targeted companies didn't set their dependencies up in such a way that to protect against that sort of confusion. So I think we'll see a little bit of that with Docker Hub.
Yeah, I don't think it
Um,
was an intentional part. It's just a way. Honestly, I think it
yeah,
was what ODG was talking about, where you use a prefix ODG dash as a way to avoid conflicts. I think that was the original intent of most of these, was conflict avoidance, but it just so
yeah,
happens it provides a similar security feature. Is you
right.
really have to intentionally take PayPal's version of a package versus somebody else's, and then you as random person X can't can't use the PayPal prefix.
Yeah. Oh, the prefixes for PHP for Compose are registered.
Hmm.
Okay.
Yeah. So for example, I have control of the pxslip /x
Hmm.
uh, domain essentially. So on packages.org, which is the central repository for Composer, if you go, Composer or packages.org/pxslip, I believe it will list all of the repositories I have on there, and nobody else can create them there until I transfer the organization to them.
Yeah.
Now
Yeah,
that
and
creates
then
problems, of course,
yeah,
with abandonware, but
yeah, yeah. I
that's
mean,
a different problem.
this is yeah. I mean, this has been an ongoing problem with the. I mean, these dependencies in some ways are good, right? That's how we get large numbers of resources, large amounts of resources. Uh,
It, it means
creating tools.
it means everybody does things the same way
Yeah.
and doesn't have to reinvent the wheel
Yeah.
every time.
Yeah. I mean,
So do you want to? I was going to say, do you want to jump into WebRTC at this point?
Yes.
I got
Yes.
distracted again.
Yeah. This unless. Yeah, so because there was no concept of ownership, as OG was saying, that this is basically a hacker created a public image that overrode or came in the search sequence before the intended private package. Crazy stuff. ODG, by the way, if you ever want me to do a thing on DNS, since we had that one-sided conversation, I'll be happy to do that. Or if you want to set up that tech channel in your Discord you talked about, I'll be happy to jump on there and we can have more of a private chat there with you and whoever else wants to join. But I'm perfectly happy to do that sometime, because that can get DNS is very intricate. It's a very clever design, but it takes a little bit of work to get around it. I'll be happy to. What's that?
I was just saying, there's a reason on the sysadmin subreddit that typically the question is, have you checked your DNS servers?
Yes.
So, one of the first troubleshooting steps.
Yeah. So ODG, let me know if you ever, if you want me to do that on my stream. I'll be happy to do a 10-minute overview of DNS. I've done that for many classes at the university, so be happy to do that. All right. So let me switch back.
Yeah, as I reclaim that screen.
I'm going to reclaim the screen and find myself there we go. Right. So and again, I need and I don't know how much you've looked at it, but this is so we're talking about WebRTC, which we actually talked about in one of our first one of our first streams, maybe first or second stream, because OBS Ninja is a WebRTC app, and I think that's one of the places we started, right? I should remember. It's only 14 episodes in. I should really remember what the heck we did.
Yeah, we talked about OBS Ninja, and it is using a WebRTC to some degree, at least partially. I think.
I think it, and some of that has to do with the fact that the standard the standard was, at least in theory, still in flux. And ODG, so we had this long conversation about DNS and how it works, and OG was commenting on when he was at university and where the internet was at, and she said he realized he was wrong. He checked the so ODG says he checked out the RFC, and DNS came out 3 years before I was at uni. My last networking training, so it probably wasn't a good course at that time. Yeah, I suspect three years into DNS coming out, there probably wasn't very much of a networking course yet on that end. So WebRTC, and what we did do is last time we looked at the timeline for, I think let's take a look at the overview right here. This is what we looked at last time. So the WebRTC standards effort started in 2011. So almost 10 years ago. And so it's been kind of lumbering along, and part of the reason for that is that it is a joint standard. What I have up here is the IETF data tracker, and what I did is I brought up the RTC web, and it is not a proposed working group. It's very much a 10-year-old, very much active working group, but nobody ever updated the web page, I suppose. That said, as you can see, the standard documents that were just published are proposed standards, because in the hierarchy of the IETF, it basically takes decades for them to become a standard as opposed to a proposed standard. So that's kind of an artifact of how the IETF does things. So this is the document list produced by this RTC web working group. But this is the IETF side. There's another half of this, and that is, there we go. That is in so this is W3 W3C, the World Wide Web Consortium, which, and I should go to the top of this document, I suppose. So the World Wide Web Consortium focused on defining an API for use with use in a browser. So and I don't know. Did you ever look at this stuff? So the RTC WebRTC API. Have you
Not
ever
the direct WebRTC API, a little bit, but the browser HTML5 media API is technically distinct. I think it was it came about at around the same time, but I have used that before. Record audio, record video, not to do the broadcasting to another place, essentially.
Yeah. So so this isn't it's in some ways a little bit unusual because things like HTTP so HTTP are basically in the IETF, and then HTML is in the World Wide Web Consortium, because they address different things. In this case, it was I think they probably correctly figured out that there was so much overlap that the two organizations had to work together, which probably lengthened the time that was needed to do this. So the WebRTC document on the World Wide Web Consortium is meant to define the API. So it would be used by people like pxslip to build applications, and this would basically it would define the interfaces, the calls that are exposed by the browser to the programmer to build applications on top of WebRTC. At the same time, there's a whole lot of networking that has to go underneath, whether it's DNS, like the conversation we had with ODG, or we'll have to talk about network address translators here in just a second, because that's going to come up as well. So the so this document describes the API, and then they reference the IETF RTC Web. When they created this, they decided WebRTC sounded better than RTC Web, I suppose. But the working group's name is backwards. So this document specifies how you get access to local media devices, webcams, desktop recordings, audio, those kinds of screen sharing, those kinds of things. And then the IETF published has published it. Obviously, the documents we're going to look at in just a second that deal with the networking aspects of this. Right. So taken together, these documents sort of define this ecosystem that makes up this set of capabilities. And so if the browsers support that, and they support it properly at the back end, so everything can talk to each other, and then we have essentially a new set of capabilities to build things like OBS Ninja and Teams and Zoom and what have you. And it goes well over and above the kind of the voice over IP environment that was created to create telephony over the internet, and it in a sense it replaces a lot of standards that came out of the ITU that basically define this sort of functionality, but for specialized non-internet devices or pre-internet devices. So there's a whole set of standards that the International Telecommunications Union published decades ago for services like ISDN. OGG says TLA spaghetti as usual. Yes. So the International Telecommunications Union, really is there are two pieces to it. The ITUR, the radio division, is very much the forefront of everything now with satellite authorizations and frequency coordination for wireless services. But the ITU-T, which dealt with telecommunications, really in some ways has diminished in importance as more and more things have happened on the internet. They're still very much active in, like low-level protocols that you need to, run fiber optics properly and those sorts of things. But they're not. But for pre-internet, there were a lot of standards coming out of the ITU-T defining how you build basically video conferencing stations that used pre-internet communications links to do pretty much what we do now on Zoom or Teams. Multiple sources of video, document camera sharing or smart whiteboard sharing, audio, of course, those kinds of things. So this, in many ways, replaces that. And so what I'm going to focus on is this kind of roadmap here. So notice that the ITF published quite a number of documents. A few of them are relatively old. There's sort of a use cases document that was finalized in 2015, so about 4 years after they started. And then there are a couple of I'm going to skip this for now. I'm going to hopefully get my tablet working here in a second and sort of draft out one of the issues, and that has to do with network address translators. But also in 2015, there was an issue was resolved basically having to do with a user giving permission for another internet station to send traffic into its network and to its device. And originally there was no good way to revoke that consent, and that was dealt with there. And also about in 2016, so about 5 years after about 5 years after this effort started, everybody settled on video processing and audio processing requirements. I saw some interesting things in here when I took a brief look at it. So this is a document that basically talks about sort of, I guess, processing and camera video, so this was an interesting one. So this document it makes some recommendations. I don't know if this is a standard or an informational document. What is its status? No, this is a standards document. So this was kind of interesting because it talks about what do you do if if you're on the receiving end of a video stream and the person sending the video stream is on a mobile and they turn their phone sideways. And so the orientation of the video changes. How do you deal with that, right? So there are, and this is again, hopefully pxslip as a programmer would never have to deal with that, because hopefully the browser implementation of WebRTC will know how to recognize that the orientation of the video changed and basically do whatever they need to do internally to change the rendering. But this is one of the interesting ones that I ran into. And then this is fairly typical for these sorts of standards. So there's this document it uses the standards language must. So if you're going to say your browser is WebRTC, is a WebRTC browser or a WebRTC compatible browser, then you have to at least implement VP8 and H.264. VP8 is unencumbered. It's licensed under basically a blanket non-royalty license by Google, and H.264 does require license payments for large content producers. There's an exemption for small numbers of users, but so this and presumably the audio documents are just the same thing. So these documents back in 2016 essentially laid out a set of sort of minimal requirements and some other interesting aspects. The World Wide Web Consortium basically references, I think, 2 documents, if I remember correctly here. Introduction, I think. There we go. 8825 and 8826. And so those are, 25 is the overview and 26 is the security framework for Grandma Wrangler says it would never thought that turning a mobile device would have something that made it into an RFC, but yeah, and this is, the IETF gets and the World Wide Web Consortium sometimes get a bad rep. I don't know very much about W3C, but the IETF is plodding and slow, and is its process of coming up with a standard is just this side of a duel with pistols at 30 paces, but they're very smart engineers that have those duels, and in the end, oftentimes they generate some really, really good stuff. And so yes, they do tend to try to be mindful of catching these sorts of things and not leaving those to chance. So there are a number of things in here that in future streams I want to spend time on. I'm going to, if I can, lately my tablet's been acting up, so bear with me here as I'm trying to see if I can get it to cooperate with me today. I may have to, it's the wireless connection on is just going bad, I think. And I don't know if it's a battery or what the issue is. We'll see if it's it tends to work for a little while and then go down. If it does, I'll just plug it in. All right, so the one of the big issues for WebRTC and a lot of the RFCs that and many that I want to look at over the course of the next month or so on our streams is the issue of a network address translator, which is generally for most people, if you're like on a residential, especially on a residential network, this is built into your router. So if you ODG says they do a lot of due diligence, but always good, but trying to cover everything needed and then test and make sure it takes a lot of time. That is absolutely correct. Right. So if you're on home internet, your network address translator is generally built into what you think of as your router. And I should say too, and when we talk about NAT, all of this discussion really is an IPv4 discussion, which is those are the addresses like 132.235.something.something. Those are IP version 4 addresses. Network address translation is unnecessary in IP version 6. You get other issues there, but so network address translators are very much an IP version 4 artifact, but they because IP version 4 obviously is still very, very much the dominant address. Basically, IPv6 is making inroads where IPv4 can't be deployed because we're out of addresses, but otherwise people use IPv4, right? And there's some other. I mean, I've fought a losing fight with the university, Ohio University, where I used to work and where I now teach again, where I retired last summer. The entire bloody university is now behind a network address translator for no bloody good reason other than that someone at Gartner said this is best practice, and so somebody else said you must follow best practice, and so they said, "Hurrah, we're doing that." And it's a mess, and you'll see in a minute why this becomes a mess. So I don't understand it. I don't believe that it really provides security. I think there are better ways of providing security, but it is what it is. In Asia. So, for example, in Japan, I think I know Japan, Taiwan. I've listened to industry talks from folks there. The computer version of political correctness. Yeah, this is even worse than political correctness. Trust me. This is the we can't do anything unless somebody else has told us that it's okay to do that. This is even worse. And Grandma Vargas says you must have some beefy firewalls fronting them to handle those translation tables. You'd be surprised what modern silicon can do. So what I was about to say, in Japan and in Taiwan, because the way the allocation policies for IPv4 addresses were set up, North America was by far the biggest consumer of IPv4 addresses and had, and so the reason we don't see much or hear much about IPv6 in North America is that we don't have an abundance of IPv4 addresses, but we have enough to function. That's not true in Asia. And so in Asia, it would not be uncommon for this you might have a residential computer. It would go through a NAT, and then the ISP would further NAT. So you run through yours, and and so these are called carrier grade network address translators. So that's so Gremlin Wrangler. That's even so think about the the horsepower you need to not just do this for a university, but let's say you do this for an entire city. The only example of this I've seen in the U.S., other than mobile carriers have been doing a lot of that. The only example I've seen in the U.S., and that service, I don't know what that is called now. One of the satellite internet providers in the U.S. was a company called Wild Blue, and I had their service for a while, and they were doing the same thing. So if you had a residential, your residential router would get a private address on the outside, and then create another private address on the inside. And the first time there was a public address, an actual routable address, was on the other side of this carrier grade network address translator. So the issue we're running into is so. Let's go back to black here. So I have, I'm going to use the old style symbol for a telephone, or just to make my life easy, right? So here's a user with a device of some sort. Think a browser, mobile, or otherwise something that can do audio, video, screen sharing, and it's connected to its router, its internal network. Actually, that. Here, let me use. So I'm going to use. I am going to use blue here. So try to make it relevant. So this is a network that uses private addresses. Right? Grandma Wrangler, my first job, I was supporting a network for mobile response vehicles. I remember that. Carrier grade net, yeah. I think it's big with ATT wireless, but it's been a bit, yeah. Because of the number of devices. Actually, if you look at the details, a lot of mobile devices use a lot of mobile devices use IPv6 internally. There's actually a lot of IPv6 in there, and if you poke around your phone long enough, you find that it has an IPv6 address, because a lot of internal, especially in a lot of internal communications within the carrier network, are actually run IPv6 in a lot of cases, or can. ODG says almost as we need to take our knowledge and redesign the internet from the ground up. Need an RTC for that one, yeah. Well, I'm working on the software that's supposed to run between here and Mars, so I'll get right on that. Internet 3, yeah, that will be one way of looking at it. So your device, private addresses, most home addresses start with 192.168, and a corporate with a corporate or carrier grade net, you'll see 10 dot something dot something. I'm contrary, so my network here at home is 10 dot something. Just I like it that way. And then your router, if you're lucky and you're on an ISP that doesn't use a carrier grade NAT, then uses its one external IPv4 address, and so it does a translation internally, changing both addresses and potentially port numbers to accommodate traffic, and it does so it does that in both it does both ways and adapts. So here's the problem: you want to talk to somebody else. Keeping the eye on the clock. So pxslip, unless we're going late today, we may not get to very much Docker, but that's okay. That means we'll have something to do for next week.
I say it gives us a built-in conversation for next week,
doesn't it? Though, let's see what. But this stuff's kind of interesting, and it is sort of at the core of what WebRTC is dealing with, right? So here's another network address translator for the other network I want to talk to. And it, of course, has its own set of addresses. Right. So if I want to create if I want to create a connection, voice or video connection between these two devices, I can't, because I can't. If I send unsolicited traffic into a network address translator, it doesn't go anywhere because there's no translation. That yellow line doesn't exist for this new traffic coming in, which creates a real problem, and it's of course also the reason why the powers that be think this thing is a security device, because it does indeed block some traffic. It just sort of accidental traffic can't get through. Malicious traffic can always find a way to get in, is my argument. But hey, who listens to me? You guys are. Thank you. That's a good thing. So a lot of what WebRTC has to deal with, and a lot of the things that we're going to talk about, is that you need a little bit of help. So to create these kinds of connections, this is one of the reasons why a broad IPv6 deployment would really fundamentally change the network in some ways. Because of these network address translators, while these devices at either end, these guys here are perfectly good web browsers, and making a request outbound is super easy. But having something unsolicited come in and be accepted is impossible. So not impossible. I can go in here and create fixed settings. So I can sort of do some configurations here. There's some tricks around this. Another reason why using that as a security device is a really bad idea. So the current internet then basically forces us into a situation where there always has to be some helper that is actually sitting in the open internet that's it's connected by public addresses. So in effect, what I have to do is, from a device that wants to initiate a connection, I want to participate in a Zoom call, or I want to talk to pxslip over WebRT over OBS Ninja. I have to go out and talk to a central server. I have to get the other person to do the same thing, and then this guy here will attempt to mediate a way in which I can prepare basically this device so that this traffic can flow directly, and this traffic can flow directly. And if you remember, and this ties back to a stream we did some number of weeks ago. Remember pxslip and I put up Wireshark and confirmed that when we set up an OBS Ninja connection, remember pxslip, when we set it up, we actually verified, and ODG, we did that in Ustream as well. We verified that we were actually flowing media directly between the two devices without going through an intermediary. And if you have some really, really silly restrictive devices, you may actually need a helper to mediate your traffic flow, which means that this guy obviously has to do a lot more work, and something that that was a fun stream, wasn't it, ODG? So the reason for this explanation here is that a lot of the things in these standards have to do with address handling requirements, right? Because in this scenario, each device has an internal address on its own network. It has this external address. It may have multiple addresses. It may, the helper device in the middle has addresses. So there's there are some really sort of weird combination of things that can happen. Also, some privacy issues. ODG, you were talking about that. One of the things that this guy who did that supply chain hack was trying to do is exfiltrate IP addresses for different devices, right? So I mean, a lot of times I don't want these internal addresses to leak. I might not want to. There's no reason to, because they're not reachable. So there's that. There is, and this was, again, this goes back to it goes back to 2015. Stun is something we're going to talk about. This is a technology that's one of the technologies you can use to facilitate this functioning as a standard that facilitates this sort of mediation function. I'm going to spend some time on a future stream talking about that. Last month they standardized the overview, security consideration, security architecture. This address handling requirements document, and this is another kind of large chunk we're going to talk about on stream, and that is that WebRTC itself does not specify a signaling protocol. It doesn't specify how you're actually going to signal intentions between devices. Right? So I want to do these things. I want to use this codec. I want to share a screen. I want to do this and that and the other. I'm assuming that I'm assuming that I haven't looked at this yet because it's a big document. I want to spend some time looking at it ahead of time. I'm assuming that this defines a possible signaling protocol. There is a protocol that was developed along with the voice over internet protocols called SIP, Session Initiation Protocol, that can be used. And in the intro document, the intro document establishes a requirement that whatever signaling WebRTC does, it has to be translatable. It doesn't have to be compatible directly with SIP, but it has to be translatable into SIP so that these different signaling protocols can at least be connected to each other in some way. There are data channels. I believe this has to do with things like screen sharing. And I'm going to spend another probably maybe an entire stream on media transport. So when we talked about iPerf and jitter and those kinds of things, we talked about the fact that we need that we need specific protocols, that are meant to carry streaming data, and that's what these are about. So there's lots of stuff to go over. Today, all I wanted to do is kind of both lay out sort of the architecture of that, and point out that a lot of this is driven by the network address translator architecture of our internet, and the fact that we have to live with that for some period of time. And so a lot of the networking aspects of it have to do with sort of piecing together lots of standards that have existed, again, for telephony, which had this exact same problem already and has had to solve it, to actually make these connections work. So there's lots to talk about, and it's very much, of course, in along the lines of what I wanted to do here. So this is as far as I want to go today. This is really just kind of and I need to, one of the things I have not done properly is I need to go back to the website and put some pointers in there. So I promise I'll go in and put these links up, so you can go and follow these and then kind of track down these standards if you're interested in a particular aspect of it. But in future streams, we're definitely going to talk about NAT traversal. We're definitely talking about signaling protocols. We're definitely talking about data transfer protocols. So lots of stuff to talk about. All right. Then with that, final, and maybe I should bring a Jamboard back up. Maybe I was premature here. Let me bring that back up and create another. There we go. Wouldn't you know it? So pxslip, you remember how much trouble I had with that tablet a couple of days ago. It's behaving itself perfectly fine. I don't know if that's because my other wireless mouse is off right now. Basically, it went to sleep or what the deal is, but I have to do some more troubleshooting on it. All right, Docker. Right, so we talked about containers. And I wanted to sort of really quickly before we we're not going to get as far today as I anticipate. Well, I mean, hey, these streams are fun. We'll just chill and do our thing. And we get where we get to, and then we'll pick it back up next week. Yes, ODG. I hope you'll be. Hope will be interesting. It's interesting to me. I hope there'll be people that find that interesting. I know I have some students in my class that need to watch because that's the class I'm teaching. So a lot of that stuff is also tied to the class I'm teaching. So we'll have we might have some interested parties there. Right. So containers are kind of interesting beasts, right? Because I think, and again, pxslip, jump in here. Anytime I sort of mischaracterize something. But the way I think about it is that when we went to the point of saying we don't want to build a hardware server for every new application we want to bring up, the idea was to take the original idea was I take hardware, I take something that's typically referred to as a hypervisor. Hyper-V is is actually the Microsoft version. And then I put an operating system and applications on top of that.
Yep. Yeah, so within the Hyper-V, you have a number of distinct, completely sandboxed operating system with all of its dependencies, the entire kernel, the whole kit and caboodle.
Well, and so for a container, yes. So originally this is a VM. Right?
Yeah, that's what I was describing. It's a VM with the full OS, all the dependencies.
Right.
Of your
so the hypervisor
everything.
is very thin. It basically mediates between the hardware and individual virtual machines and gives a sort of a hardware-like interface. But each new application you roll out, you install a full operating system and a set of applications. And the way I sort of look at that transition is, I mean, Docker has to, Docker containers still have to run on hardware somewhere. Typically now, and this is where things get a little fuzzy for me. Oh, there goes my tablet again.
You jinxed it.
I jinxed it. I should not have said a thing. I've replaced the battery once already. I'm wondering if the charging circuitry isn't getting. I mean, I've had this tablet for a while, so. All right. So I'll have to have hardware. In this case, I have a single instance of an OS.
Mm-hmm.
I have the. Let's just focus on Docker because that is kind of the container shim of choice.
Yeah.
Right, so I have the Docker service running on top of an OS, and I think what that buys me, and this is where you need to just help me out a little bit. So here's where we're running containers above the Docker layer.
I would actually even, and this is sort of the difference. It runs next to the Docker layer. So you don't have the space there on your diagram. This is really sort of where VMs and containers start diverging. A container is essentially an overlay on top of the operating system that is running.
Gotcha.
It
So
is
let me
I
try
have
it this way.
access.
Yeah. Okay.
I
Keep
have
talking now
access
while I erase
to
here.
this exact same kernel and other information that is potentially is running within your OS, typically Linux. Windows works as well. Mac will never work. I almost guarantee you.
All right.
That would require the
Mostly because of licensing and nothing else.
yeah, I imagine so. Point being, right, it is going to sit on top of your kernel and it's just going to create this little overlay. If you're familiar with Linux, this is getting into deep cuts. It's started out using chroot. Yeah, essentially Gremlin. Yeah, Docker is essentially just
so
orchestrates.
I wanted to. So maybe this is a better. Right. So I've got Docker sitting here. It exposes a user interface towards me, so I can control what's going on. But it orchestrates the containers in some way.
I will comment though, Gremlin, that be careful. Orchestrators in sort of Docker land have a very specific.
Yes, that I was going to say
meaning.
that word is overloaded. Yeah, so
yeah. So in this case, you are accurate.
It's like a control plane.
Yeah.
In networking, would call this a control plane. It's how you actually tell the containers what to do, but the containers basically have sort of a sandboxed interface into the operating system. So the container itself doesn't have to contain the entire operating system, although it generally contains pieces of one.
Yeah, it essentially pulls in the bits and pieces it needs, or pulls in the parts that the base layer may not have or may not provide. But yeah, ODG is sort of along those lines.
Let's reread that for a second.
Yeah,
So
I'm sorry.
said,
the question is Docker like an API to the OS, but common API across platforms rather than a complete machine? So you don't need functionality in Docker that the OS can provide, making it smaller than a virtual machine. So sort of trying to pull out what I understand from there is it is essentially yes, right? Docker is providing this common way to understand it, and this way to and I'm going to use this word, and I dislike it because it like we mentioned, orchestrate is overloaded in this context, but it orchestrates pulling down Docker images, which are in and of themselves made up of layers. So basically, all that happens is Docker provides this mechanism for laying these one layer after another layer on top of the existing kernel. So if you're familiar with the chroot, that it's an old Linux thing. That is actually the core functionality of Docker. Is essentially it is this big, massive wrapper around chroot.
Yeah. So the yeah, and I don't know. A Linux kernel is generally a Linux kernel, but you could have version mismatches there too. But
yes,
like a Docker container, it can be based on Alpine or Ubuntu
and you can
or
specify
Debian.
specific versions of Alpine. So that is
right.
You're absolutely right. I don't know the answer to that.
And so there's sort of the container itself is layered, I suspect, in a sense that it has to be an adaptation that the ODG, I think is more. I think it was more as an API translator, right? So you rely on the underlying OS to do the heavy lifting, but you have to. But if the container is based on something slightly different from the underlying OS, you have to have an adaptation. Which is not part of the runtime Docker, but it's part of the construction mechanism.
Yeah, and
right?
that is the piece that the someone with 2 PhDs and has been working on the Linux kernel for 20 years is comfortable touching.
Right.
I couldn't tell you how that works or what it exactly it does. I know it works,
and
I know conceptually that it does not come bearing an entire OS. How it handles that, who knows?
Yeah. Well, and so I think one thing is illustrative for this. So ODG, this is something I struggle with, and I still struggle with, try to totally understand. But I think there's a reasonably accurate description, right? So that's assuming my OS is Linux. I'm running a container that is also Linux, although maybe not exactly the same version. So the easy part is if I want a different shell, or if I wanted, I think. If I wanted different, so this, let's say this operating system has a GCC 10 compiler. I want GCC 9. The container can basically can overlay the OS in such a way that from anything running in the container sees GCC 9, even though the underlying OS is GCC 10, that sort of thing. The container is not so much the bottom of the container is a shim. It's a translator. And I think what I was getting to was this is most visible when you try to mismatch operating systems, which is possible, right? So pxslip said correctly, and most Docker hosting services run on Linux servers.
Yeah.
And so they're perfectly well suited for running Linux containers, subject to some level of translation. So what if I wanted to run Windows in my container? Now I've got a problem, right? And
I don't think you can't run pure Windows containers on a Linux Docker host.
Right. Because it's just that translation really doesn't exist to my knowledge. It might.
No, I mean
you could. So spin that tail a little bit further. Of course, there's one service that is at least partially Windows-based, and that is Microsoft Azure for obvious reasons. So the reverse is possible. I can have the OS be Windows, and I can have the container be Linux, but it in effect sticks a hypervisor in the middle.
Yeah. So at that point, so for example, Docker for Windows is actually running a VM.
Yeah. Right.
It's a different hypervisor depending on, and it's not even a pure hypervisor at some point. But if you are running Docker on Windows and attempting to run a Linux container on Docker for Windows, sorry, a lot of qualifiers there, then you are essentially running a VM with Linux in it.
Right. So these things work, but these things were designed, and then they got sort of expanded a little bit, but they really designed so that for cases where the underlying OS is well suited to provide the necessary services the container's running on top. ODG, I hope that sort of helped a little bit, because I think that was kind of an interesting recognition for me. Is like what we just talked about, the fact that there are some combination of containers and host operating systems that are either impossible or require just a lot more heavyweight stuff. So with that kind of as a background, what I want to do a little bit today, since we're already at 9:30, and then definitely a lot more next week, is to look at what this actually looks like in a real example. And so I hate dragging stuff on. This doesn't have the dragging problem. It wants to snap between my monitors problem.
So I use the keyboard shortcuts. They make life a little easier.
Yeah, I agree. All right, so
You, I think, are gonna have to zoom that in a little bit.
yep, I'm working on it. So I have Docker running here, so let's just so what I'm going to do here is something like this. So this is, I'm actually this is not on my local machine, so this is not Windows. This is a Linux machine in another room in my house that I'm SSH'd into, and so I have Docker installed. I have 3 containers locally available, and if I call for a container that isn't locally available, the Docker command generally will just pull it down from Docker Hub. So, and this is where ODG. This is where we were talking about earlier about some of the naming. So and again, pxslip jump in here, but so I've got an example here. I pulled down an iperf container, and so this one has a prefix that is tied to the Docker Hub username.
Presumably, you could have an organization. I haven't. I only use Docker Hub as an individual.
Yes, Docker Hub has an enterprise
So you could have your organization as the prefix.
So it could be Apple or whatever. Yeah. And so and I think again in Docker Hub's case, a lot of this has to do with avoiding naming conflicts, because there actually are about 100 different containers called iperf or iperf3.
Yeah, I mean, think about how many Apache containers do you think there
Apache
are?
or Nginx or something, right?
Or right. There's one for about every other web developer on the planet.
Yeah. But of course the other aspect of this is that it prevents me from accidentally grabbing the wrong or maybe a malicious version of the container, which would be bad.
Unprefixed ones. So you see that you have 2 unprefixed ones. Those are either local. You built them yourselves on your local machine. You cannot push them to Docker Hub or a central repository. I think some repositories may allow it, but most public ones wouldn't. Or they are controlled by their Docker official. They are the core images that the rest of the world builds their images upon.
Hello World is definitely that. I don't know why GCC isn't.
Because
it's got to be a core
by Docker.
I think it's a core one. That's why it's. Yeah. So I think there's and this is not something we're going to get into tonight, but pxslip, I think I saw there is the Docker I think it's a tag command lets you attack. I mean, I could take a container I build myself and add a repository name to it, at which point it should be pushed. I should be able to push it, assuming I'm authenticated.
Yeah, you would name and tag your image correctly for the Docker Hub
with this sort of repository / naming convention. So these are the containers, and so the point of these is that each of these containers is designed to perform a particular function. And in fact, let me see. I think maybe a good way to do this. Do I have that up? That's a Docker. Nope, but I can get to it. Hold on a second. Projects. There he is. All right. So this is the. I need to expand that. So this is the Docker Hub page for Michael Labby, I think is the full name, and I know that because of his GitHub name. So this is a this is the page for this container on Docker Hub, and a lot of them, not all of them, but a lot of them have an associated GitLab, GitHub page.
Some of them will be GitLab. Yeah, it's not as common, but they are there.
Right, and so and so what's kind of instructive here is that so this is kind of opaque, right? I mean, this gives me lots of instructions on how to run it. And if I know what I'm doing, it gives me the Docker command to run it, and we'll try that out in just a second. But if I want to know what's behind the scenes, and this is, I think, where we loop back to the discussion we just had up to now. This is I picked this because it's a really super simple setup. It's a very I suppose common one too. There's really nothing in here. There's a README file and a license file which get auto-created when you create a GitHub repo. So the only thing in here really is the Docker file. And so let's take a look at it. And it's a nice short one too, which I also liked. And so I think ODG and Gremlin, so this is to me, this helps me understand what is actually happening in a container. This is the precursor to the container. So on my, the thing I listed here, this is a binary file that I can execute with Docker. And when I do, it will perform the functions I asked it to do. But somebody had to build this binary file. These are the instructions that Docker will use to build that binary file.
And remember how we were talking about layers? This is where those layers get defined.
Yes.
So there's essentially one known layer on Docker Hub for the Alpine latest image.
Yep.
So I start with that layer, and then
By the way, let me
creates a layer.
Let me ask you a chicken and egg question. What is the who built the first container that had no from statement in it?
I would assume that it was essentially so what it will be. I actually can say this with some idea of certainty. What it would be someone compiling the kernel from source.
Yeah,
right.
That was my guess, right?
You're going to be sitting in a repository or a directory with the Linux kernel source code,
right,
and a Docker file.
Yes.
Compiles that kernel from source.
Yeah, you're right. So ODG is saying I've done some of this. Using it's not always the same as understanding or being able to explain it, which is why we're kind of working through this step by step, right? So there are a large but manageable number of base containers that most people will start with if they're not going through the process that pxslip just described, right? So generally, you pick a let's stick with Linux-based containers. So generally, you pick a distribution you like, and so Alpine is one of them. There are several others.
I mean, any of the ones that you would normally run on Alpine, Debian, CentOS. Well, not CentOS anymore, but Red Hat.
Right. But then there are also some specialized ones. There's a lot of like BusyBox. There are a number of.
I think BusyBox is the most pared down thing you can find. It really is. I think basically just a shell.
These are meant for like super tiny Linux images for embedded systems. And so because containers are meant to be fairly lightweight and generally don't have to be sort of a jack of all trades, it sort of makes sense that a lot of containers are built not on top of something like Ubuntu, which is a full-fledged Linux distribution, but something more lightweight. So the starting point of layering is that we basically start with one of these prototypical, primordial containers that we don't know how to build, but it's good that they're there. This is done in the name and tag format. And so right now we could specify a particular Alpine version that was important to us, but we're basically saying grab whatever the latest version of the Alpine container is. I want that. There's some built-in documentation. In this case, there's a so you could ask. So if I didn't have the Docker file available, I could still use the Docker command to. I think it's inspect. I think it is.
Mm-hmm.
Let me see if that's true. Good God, yes, it will tell me all sorts of things. I wonder if it's an output format that does not put this in JSON.
Oh, I have absolutely no idea.
But anyway, I noticed that the maintainer is in here somewhere. So there it is. So you can get to this information even if you don't have access to the Docker file. This is just easy to read, much easier to read.
You're not used to reading JSON all day long?
No, I despise JSON for readability. It is very useful, but no. That's just me. All right, so the from statement basically says this is a bottom layer. We'll start with a primordial container that contains all the stuff that whoever built Alpine put in there. Now I have to layer on top of that additional functionality, and that tends to ODG says reading JSON to me is like reading XML, which is that's actually fairly similar. You're right. So at this point, in most cases, the next few things really look a lot more like things you would do once you're logged into a new VM. Right, so in this case, there's a run command. So, this does not happen. pxslip, correct me if I'm wrong. This does not happen when you start the container. This happens when you build the container.
Correct.
So when I tell Docker to build this container from scratch, it would start with the Alpine container. The run command would basically have it grab a shell and then run as this Alpine package.
Just because the language here gets so particular. Technically, this is an image, not a container. The container would be when I have deployed said image using Docker or another container tool.
So I start with a base image, a primordial image.
Mm-hmm.
Yes.
Yeah.
And so
that would be my understanding of it. Yeah.
So Docker will then, based on that image, run. APK is the Alpine Package Manager. I can't remember
literally what it stands for.
It's Alpine Package.
Package. There's another name for it. I don't remember
They
now.
did something weird, but anyway.
Yeah.
So it installs iPerf 3. Creates an iPerf user. It switches the user that executes the command that the container, when deployed, is supposed to be running to iPerf. I think these are not strictly necessary, but you can basically this at least documents and to some extent identifies what ports should be open for traffic in and out of the container. And there is a way to sort of temporarily map these, I think, when you run the image to create the container, but generally that's done a little bit differently. But let's see. Let me catch up in chat here. So run executes a command line for whatever the container was built on. Yeah. So I think that's the best way of thinking about it, right? So you start with an Alpine image. You have essentially the Alpine operating system, the equivalent of the Alpine operating system with its utilities available to you. And so run will, I'm assuming, pick the default shell and execute the commands you specify. So there's a PC, then expose would equate to setting a firewall port. Yeah, it's a little bit like I think it tells. This is one of multiple ways to tell Docker that you want how to configure networking in and out of the container. As in general, most containers really aren't terribly useful if they can't talk to the. I mean, there's some exceptions to that, but generally, most containers in the context of what we're talking about here will need to be available to provide web services via network traffic. And so in effect, it's ODG is very similar to basically setting permit rules on a firewall. So the last is I'm going to skip over here one of these, but there's a combination of two instructions here that govern how what happens when you tell Docker to run that image. And one of them defines the executable in this case. Could be a shell script. It could be pretty much, but it has to be something that can be executed. It sets the entry point. So this is the program we want to run when the image is executed by Docker. And this is sort of complementary with the CMD statement. I'm pretty sure, just use a CMD statement and put iperf3-s in the CMD statement.
I always have to look this up. Basically, it changes how you interact with the start command when I, the user of your image, are trying to start it as a container. If you use entry point, I have to override it using a flag -- entry point. If you provide it as a command, it's just I can basically tack things onto it. So command will tack on to entry point, and I can then add additional flags to the iperf3.
And that may even be a way to override what's in CMD, although I don't know that.
I believe if you I think it will be overridden. I'd have to double check, but I believe it will be overridden by anything you add, basically anything you append on the run command. But I would want to confirm that.
Yeah, I think those are some things to play with, but that's basically the difference. Is the idea is that the CMD provides some default parameters to the program you're going to run. If I put iperf here, how I change what the container does at the start would change. ODG says I was confused with the CMD entry point, but read one was interchangeable from the command line Docker run command, the other can't. That's right. So, well, yeah, you can override both, but the mechanics are different. And the Docker for the CMD statement is meant to be overridden or augmented at the time of Docker execution.
Glancing at a quick article, it is overridden. So if I pass additional parameters to the Docker run command, it will override CMD. Entry point will be appended to entry point,
but override CMD.
CMD are essentially the defaults.
Okay. And then the final bit here is really is, if I've read up on it correctly. So if you look at it, what this thing is, since when this image is executed, so this container is actually running, you have iperf running. So what the health check statement does, that's a one part ODG that I'm still going to experiment with. It sounds so. Yes, I think that's our understanding. Is that if you specify command line, it overrides what's in CMD. So if I wanted something other than just -s, I would have to specify -s something or whatever. That's at least that's what I'm guessing.
Yeah,
that would
that
make
is
sense.
my understanding of it.
Yeah.
And I will respond. I don't think you did, but he was asking about the expose command equate to setting a
Oh,
firewall
I'm
port.
sorry.
Yeah, no. Yeah, that's essentially exactly it. It when an expose command tells the container runtime, hey, this image wants you to assign a port to it that will be mapped internally to this port on the container.
Yeah. All right. So we're coming up on about 2 hours, which seems to be pretty much our time span these days. So let's do this. Let's try and run this
Yeah.
image
Yep.
and see if it's
Let's do that.
working. So let me see if I can move this. We'll go back over here because he sort of was kind enough to provide the Docker run command more or less.
Yep.
So I will take shameless advantage of that. Make my window a little bit smaller. Now, I think I'm gonna, from what we talked about earlier, pxslip, I think I'm gonna leave. If I leave the D off, then I should get the output from the container. And
I believe so. Let me
let's
see.
give it
Let's
a
see
try, right? So the idea is that uh, to make it easier for me to recognize what I'm doing, he's correctly suggesting that I should give this container a name. I'm just going to call it iperf3. I'm going to leave the D off, which would put which will detach the container and leave it running on its own until I use a Docker command to stop it. I'm going to not worry about the restart. We're going to map, and so ODG, this is the other place where you set up those firewall rules, and this is actually a lot more intuitive, right? So I'm basically saying map. I think this is host port 5202 to container port 5202 for TCP, and I'm going to do the same thing for UDP. So I want both. Not for tonight, probably, but normally this is what we would want to do. All right, so that should set up the firewall mapping, essentially. And then I have to tell it what I want to run. And that would be that one. That should work, right?
As far as I know.
Oh.
You have a container running.
Let's see.
Or rename that container, yeah.
It's not running.
You have one. Yeah, it's not running. It's just there is a.
Oh, okay. Well, how do I list all I listed images, but I know they list containers. This Docker container. Container list. Nope. Can you look it up for me?
Docker container ls. Try
That's
that
what I
for
did.
me.
And it doesn't show anything.
Yeah, but that's what it said. I'm sorry. -a.
Oh. Otherwise,
it only shows you running. Otherwise.
Yeah. There we go. So I need to kill off the one. Okay. So how do I get rid of stuff from here?
I believe Docker rm, but let me double check what the flags are to that.
ODG says, even though I've done this, it's always good to have my self-learning confirmed or corrected. Always aware that I probably misunderstand some things. DNS stuff or something like that. No worries.
I believe you can just pass the. I think you can just pass the container name. So Docker rm
iperf3.
Yeah.
And away it goes, my precious.
Yep, that worked.
Okay.
Love it.
All right. So now we try to start run it again. Okay, that was a good thing to learn. Interesting. So it did not. Oh, it probably buffers. It probably buffers. So now I need another command prompt.
What did you mention something about vCore? Not. I don't think I've ever heard of it. Oh, VS Code or Visual VS Code or
Yeah, let's do this.
yeah, there's a built-in integration. Assuming you're talking about VS Code, yeah, there's a pretty nice little built-in integration. It'll happily purge your containers for you, stuff like that. There's also on. No, I say I don't blame you. Typing fails me all the time. There is also, at least on Windows and Mac, and I'm assuming on a Linux machine with a window manager, there is a dashboard that comes with the Docker desktop application. So
Yep. So, all right. So let me just set the stage here. So this is the output from the. This is now a container since we ran the image. You notice that it's actually getting very short connections from somewhere, from itself. That's the health check. So now we're going to, from my machine here, we're going to try and connect over there. And so it looks like we're doing that. And the server hasn't caught up. There we go. So the output, the output from the container is buffered. That's why it took a while to show up. So, so basically, I ran an iPerf connection from this machine to my other machine without actually having installed iPerf or run iPerf 3 natively on that machine. Right. So that's the point of the Docker image. Right, so I think we're gonna. I think this is a good stopping point. Where we're going to go next, and I promise this will be next week. Where we go next is we're going to play around with this. For one thing, I want to see what the. I want to see. I want to play around with these overrides, right? So I want to see what happens if I play around with command parameters for the container. We are going to play around with. Creating a permanent log file that exists after the container exits, and a couple other odds and ends, and then we'll modify this and actually rebuild a container with iPerf 2, and maybe some other bells and whistles of what we want, to kind of go through that process of doing that. pxslip, anything else before we wrap up for tonight? If not, we are going. Let me take a look and see. Lygia, if you've taken a look at, is Fern on yet? She is. She says, I've heard Docker can be heavy on networks, but I'm not sure that's correct. It'd also be an interesting thing to look at.
No, it absolutely can be, OG. Because it's downloading all of those layers, you create a large image, and each layer, right? Every time the image changes, if you change it too early, it has to re-download every layer. Now, if you're smart about it, you do all of your base work early on in a Docker file, so that the layers are stacked in such a way that the changes only are pretty minimal. But that
I think the other reason, the other aspect that could have led to a comment like that, ODG, is that container-based applications are often deployed with lots of small containers that all have to talk to each other.
Yeah, that's a good point as well. Yeah, microservices, right? Nano services, even.
Right. So one of the things that we haven't explored here, and that we're I sort of think about whether there's a so ODG, it should not be heavy if you're just running a single image on your machine. Because at that point it's pulled everything, and it's almost like running a tiny VM, and it should not. It shouldn't have any network impact. The problem is if you have an application that has 4 or 5 containers that run different parts of a service, they all have to talk to each other, right? And so it creates a load on your machine because your machine is essentially supporting a virtual network. Everything's talking over essentially loopback ports. I'm assuming.
Mm-hmm. Yeah, it creates
Docker
an
would create
internal.
kind of an internal network, and so at that point, your machine, your host machine, is doing a lot more sort of internal packet routing than it's normally designed to do.
Yeah.
So I wouldn't think it's running a single image. I think is pretty neutral. I think that's going to. As pxslip said, building the image is just like downloading software, right? Because you pull in bits and pieces for the during the build process, which we'll look at next week. And then, but then once that image is running, Docker should not create certainly not a lot of network load at that point. But once you deploy multi-container applications, it gets a bit different. All right. So as we wrap up here, as we often do, we are going to hop on over and finish the evening with some music by Resurrection Fern. So we'll raid her channel, and hopefully I'll see some of you over there. I will try to initiate a raid here. It looks like the countdown has started, so I will see you next week, I hope. Thanks for being here. Appreciate it very much, and we will see you next week.